In many ways, Honda can best be defined by its pioneering research and development in advanced humanoid robotics. It requires state-of-the-art technology, a spirit of innovation, a dedication to enhancing people's day-to-day lives by expanding mobility, and a focus on serving customers and creating products that benefit society. In a world designed for humans, engineers began by focusing on developing legs that could walk independently. And in 1986, Honda's first experimental humanoid robot, E0, took its first successful steps. But E0 could only walk slowly in a straight line. Known as static walking, this is different to the way humans walk. So Honda's engineers looked closely at how people walked and maintained balance to better understand the mechanisms of movement. In their study, they found that when humans walk, they get just off balance, as if they were about to fall forward. This walking while falling is very difficult to simulate in a robot. In 1988, a breakthrough was made with the E2 experimental robot, and successive robots in the E-series made additional progress. However, all E-series robots lacked a torso. The engineers' next major challenge was to create a complete robot with a body as lightweight and efficient as possible. These efforts led to the introduction of P1 in 1993. P1 had a somewhat rugged appearance, but at last a humanoid robot had been created. In 1996, engineers reached a number of additional milestones in its second prototype humanoid robot, P2. And later, an all-new prototype robot, P3, was introduced, the world's first completely independent walking humanoid robot. The next stage of the dream challenged engineers to create something that could function in an actual human living environment to better enable it to help people. The result was ASIMO, an acronym for Advanced Step in Innovative Mobility. First introduced in 2000, ASIMO achieved better balance, was more nimble on its feet, featured a sleek, stylish design, and was capable of simple operations within a human living environment. ASIMO's height was an important strategic decision. Its size allows it to easily operate in a human environment, and its eyes are located at the same height of those of a seated adult. Since its introduction, Honda engineers have continued to refine and improve ASIMO, and in 2005, these efforts led to a new generation being unveiled. This ASIMO could carry out a number of simple tasks, such as pushing a trolley or delivering a tray, and most impressively, ASIMO could now run. Further advances came in 2007, enabling ASIMO to collaborate with other robots and even recharge itself when low on power. Up until this point, ASIMO was an automatic machine, relying on programming and human input to execute a task. So the next major step was to develop a more intelligent robot that could adapt its behaviour to its surroundings. This scientific endeavour led to the latest generation of Honda's humanoid robot, the all-new ASIMO. Honda's engineers had now created a robot with a degree of autonomy, with an ability to make simple decisions all by itself. With multi-fingered hands, ASIMO could now also perform complex tasks requiring dexterity, such as opening a bottle, pouring a drink, and even expressing sign language. And equipped with stronger and more dynamic legs, it could also walk on uneven surfaces, run faster, run backwards, jump, and even hop on one leg. ASIMO heralds the beginning of an exciting future. Acting as a catalyst for further innovation, Honda engineers are exploring a number of technologies and next-generation mobility products, all made possible from their pioneering research into humanoid robotics. From devices to help those with walking difficulties, to new forms of personal mobility, such as the Unicub. The development of ASIMO is opening up new frontiers. Much work still remains, but with ASIMO, Honda has truly taken an advanced step in innovative mobility.